Next
다음
presentation.
발표는 KIOST의 해양위성센터 유지영
Next presenter is
박사님께서
Dr. Ryu
드론과 인공지능을
Joo-Hyung
이용한 대형
from
저소동물
the
공간 연구
KIOST.
구축을 주제로
Dr.
발표하시겠습니다.
Ryu is the
이
principal researcher
박사님은
scientist at
연세대학교
the
지구
KIOST,
시스템과학과에서
and Dr.
원격 탐사 전공을
Ryu
학위를 받으셨고
got his degree from
현재는
Yonsei
다양한 플랫폼의 원격 탐사 자료를
University,
이용해서 갯벌에서의 지형도 제작,
and
표층 퇴적상
he has an
분류,
expertise in oceanography, in the mud, and
분석 기술
the
개발
stationary
등의 임무를 수행하고
orbit
계십니다. 박수로 맞이하겠습니다.
satellite. So please welcome the presenter with a round of applause.
네, 안녕하세요. 해양위성센터 유주영입니다.
Good
오늘
afternoon,
드릴
everyone.
말씀은 일단 첫
I'm Ryu
페이지에서
Joo-hyoung,
청색 기술의
and
의미를
what I'm
오늘
gonna
배웠는데
talk to you
그것부터
about is
말씀드리겠습니다.
blue technology.
전통적으로
I
갯벌, 우리나라
learned
갯벌에
about the
대해서
concept
연구를 키오스트 코르디에서는
quite
30년 동안
recently.
30년 이상 연구를 해왔고요.
So
전통적인 방법은
I've
뭐냐면 생물은 일단
so there's been a
삽이랑
research
채를 들고 갑니다. 그래갖고
on
방향물을
the
던져놓고
mud
삽질을 해서
ecosystem,
채를 치고
and
물
what you
들어오기
basically
전까지
do
몇 점점 하고 나오는
is
게
you
생물이고요.
go there
지질
with
분야는
a shovel
샘플을
and
합니다.
all this
그러면
device,
갈수록
and you wait
짐은
until
무거워집니다.
the
그럼 물 들어올
tide
때쯤 되면 이제
tide goes off,
흙이
and
가득
then
차서
you collect some
힘들게 나오곤
species,
하는데
and then you have to crawl
우리나라
out of the
말에
mud
뻘진시란 게 있고
with all the
거기에 이제 뻘짓
mud
거리까지 붙으면 뭐 쓸데없는
in
일
your
뭐 이런 의미인데
backpacks. So
저희는
mud,
그걸 업으로
we
해왔습니다.
have this Korean expression
그런
뻘지,
거를 해오다가
which refers to
제가 생물하는
the things that you do
분이랑
with
저랑
to
걸으면서
no avail, and
이 갯벌에 있는 구멍을 보면
and you make a mess, but you don't get
있거든요.
much out of
이
it. So
구멍과 그 주변에 그 생물이
you
먹고 뭐
go
배출한
to
섭식
the
흔적, 섭식 활동의 흔적을 보면 알 수 있겠냐
mud
했더니
flat,
알 수 있겠다고
and you
그러고
see some holes
저희가
through which some
맞춰보라고
species
그러고서 삽질해서
poke
확인해
out.
보면 맞고 거의
So you
생물하신 분들은
put a shovel in the
90%
hole,
이상 100% 가까이
and in most
맞추시더라고요.
cases
구멍만
you get
봐도
the
표층에서의
you get the
구멍만
animal.
봐도 거기서
And
이
if you're an
사업을
expert
시작하게
biologist,
됐습니다. 그러면
you see a hole,
제가
you see a hole, what it looks like,
사람이
and
보는
you kind of
정도의
guess
해상도로 찍어서
what the animal will be.
그걸 주면 그 자료를 학습시킬 수
So what
있겠느냐
if we can take a photo of this mud flat with holes in it and have the machine
그리고
learn
우리나라 갯벌은 전체
what species are lying in these holes, then that will be phenomenal, right? So that's the basic idea of my study.
세계적으로
So
제일 큰
Korea has
이슈라고 그럴까 우리나라 갯벌만
2.5% of its land
자연보호도
as
해야
mud
되고
flat,
거기서
which is larger than 2,000 square kilometers. And mud flat is also a great source of economy because it produces animals, something that we can eat.
되긴 하지만 뭐 유럽이나 미국에서는 보호만 하고
We have some mud flats designated as the World Heritage by the UNESCO, and China and the US have their own mud flats, but they only protect the area. They're not designated by the UNESCO as the World Heritage. That's the difference.
수산물 그러니까 갯벌
And
양식이
the four
이루어지고
mud
있는
flats in
지역들입니다.
the Korean Peninsula, all of them are known for
결국 제가 말씀드린 대로
aquatic,
이 구멍만 보고 찾을 수
aqua farms.
있느냐 해서 이제 저희가 타겟
So they're a great source of protein.
12개 정도를 생각을 했고요. 근데 이
And
구멍이 너무 작다 보니까
this is the background
이런 연구를 한
of my
데는
research. So
없습니다.
you
적어도
see
10cm
12
이상,
holes
30cm
with
정도
different
되는 거를
species
찾지
that could be lying or hiding inside them.
1.62cm를
It's very,
찾아야 됩니다.
very small.
그러려면
Very small, like
드론이
1.62
낮게 날아야
centimeters small.
그래서
And
이
well, you can use
5m 이내로
drones,
날아야
of
되고
course, but drones have to
공간
fly
해상도라고
very,
저희가
very
얘기를
low.
하는데
less than shorter than 5 meters high, and the resolution must be super high to the level of 1 millimeter. So it was really hard for us to take a photo of this, and we have our own know-how. So we build training data and we set machine learning data. We get the data and we put the data into a system. But this is the direction of our research. This is the target of our research. So in order for us to be able to do that, we need to have a good learning data. So we have to build a data set by taking photos and inputting data for each hole and everything. So we recruited some part-timers, but it turned out we needed experts because any random part-timer students or any non-researcher, non-experts can't pick up all the holes. And as you can imagine, it's really physically demanding. You need to have a good eyesight to identify all the holes. So it takes time, it takes money, it takes a lot of people's work. So we easily talk about using the AI technology, but before using the technology, we have to make sure that this is done as a precondition to work that's going to be used by the AI. So we are continuously improving our data quality. So in order to be able to know the species for any specific hole, or to know the population of any species, what we do is to use the AI technology that will be added to the existing biology. So if you look at these crabs, you can see how their claws are quite big. And by looking at the size of their claws, you can make a prediction of the size. And another thing is that these crabs move. Sometimes they throw away, they desert their existing hole to move into another one, the new one. So this is the picture that we envision in our head. So basically, you need to have the species with the size of the species.
모 전자회사 보면 CF에 이렇게 둘러넣어서 아무것도 하지 않아도 모든 게
Well, sometimes you get this
세상인데
delusion that AI will do everything for you. You don't have to do any manual work. So that's the world that I truly envision, that I truly dream of. I don't want to do any more manual work, but that is impossible. We have to do all this budget, all this manual work. We have to go through all these hassles, and it takes a lot of time. Takes a lot of money, of course, for designing the AI technology that will be more accurate, that will be more. That will do more work for us. But what we are thinking for more efficient monitoring system. But if you look at this slide, the mudflat, any mudflat has a very small gradient. But it's not very sharp. It's not very big. a big gradient, but very small gradient. So,
혈관 같은
and you might
역할을 하거든요.
you might have taken as some sort of blood vein, but no, it's actually
뻘이 많은 지역이고 주류로가 복잡한 걸 알 수 있고 이쪽은 모래가 많은 지역으로 주류로가 심플하고 넓습니다.
of wave,
우리가 이것만 봐도
flow of wave
퇴적상이 뭘로
that's in the mudflat, that's beneath the mudflat. And if you look at these vein-like lines, you can kind of predict the conditions of the mudflat. So, for example, this area is a little bit higher than the right side area. Again, the gradient is very small, but it has some differences. So the water rarely touches the left side area quite later as compared to the right side. So there's going to be some difference in water density or water level, for example. So you can get a lot of data from out of this simple picture. And you can see the legend here, 10 categories of color coding. And this is the result. Well, if you do it manually, it usually takes about 3 months to get this result. And even if you use drones, you won't get this level of resolution. But you will have like 75% of accuracy at least. So you can know like geography or the composition of the land, whether it's sand or whether it's mud, then you can pretty accurately predict or know with what kind of species are living there. And also because of the salinity, the species that are living there might be different. So usually you use 3 factors. You need 3 factors to make a prediction about the habitat or ecosystem of any certain section. So there's this line. And if you capture this with high resolution of 5 meters, for example, and you can see you can get the data from this and take a snapshot, like the ones that I showed you. So what we have is high resolution. That is 1 millimeter level, and we also have the satellite that can take photos at different altitudes. And this system can be used for different purposes. It can be used for coastal monitoring or ship monitoring or mudflat monitoring. So our aim is to build this comprehensive system or platform that can be used in many different ways by humans to suit their purposes. And we conducted a literature review using the Chanlian satellite that we have. And it's been up there since 2010. And 500 papers were published. 500 articles have been published using this satellite data. Since 2010, and 30% of such papers used AI technology, and that percentage goes up if you come more recently to 50%. So it shows without AI technology, any kind of analysis will be impossible. So resolution from 1 millimeter to 250 meters, the system resolution could be different, it could be diverse, but it has only one aim. Can it allow us to see what we want to see? And the research must go on to reach that target. So one difference of using drone is that all the process became so simple. So you only need one drone and batteries, these spare batteries, and coffee dripper. So all you have to do is put the drone to fly, and then you drip the coffee and you enjoy your coffee until you have to exchange the battery. So that's all you do. So this is how conveniently we do the research these days. So thank you very much for listening to my presentation.